Alright students, welcome to the midterm review. So hopefully you had a chance to actually work through these problems. If you haven't, I encourage you to go back to Titanium, download the practice problems, work through them, and then come back and watch this video. If you're ready to work through them, great. We'll go through the answers, have some brief explanations, and see how you do. Alright, so question 1. A blank is a segment of a group of people that you actually end up studying and collecting data from. Is it a community, a population, participants, or a sample? So it is a sample. So a sample is a segment of a group of people that you actually end up studying and getting the data from. So who do we try to infer to from our sample? That will be our population. Our participants, those are the people we actually end up studying. Those are the people or the cases that make up the sample. In a community, well, that's not really anything in statistics, that's probably just more of a variable. So a sample is a segment of a group of people that you actually end up studying and collecting data from. Question 2. When we calculate and present data from an entire population, the numbers are called what? Statistics, inferential, descriptive, or parameters? Well, do you remember me saying SNS and PMP in the very first week? SNS and PMP, what does that mean? Well, let's start with PMP. PMP means population and parameters, or SNS means sample and statistics. So whenever we have data and numbers that are talking about and describing an entire population, those numbers are called parameters. But if we have numbers that are calculated and represent and summarize data from a sample of people, those are called statistics. What are inferential numbers? Well, those are really inferential statistics that allow us, when we have a combination of descriptive and inferential statistics, to really do some hypothesis testing. And inferential statistics are really being able to infer or generalize data from a sample to a larger population. And what are descriptive statistics, or descriptive numbers? Well, these are descriptive statistics that really describe or summarize a large amount of data that make it easy for us to really see if there are any patterns or trends that are going on. Question 3. Which of the following statements are true? Well, let's start with statement number 1. All variables can be classified as quantitative or categorical variables. Is this true or false? Well, we have 4 levels of measurement: nominal, ordinal, interval, and ratio. And if we think about those 4 levels of measurements, 2 of those fall into a category, and 2 of them fall into another type of category. Do you know what I'm thinking of? Well, nominal and ordinal variables are categorical or qualitative variables, where the responses or categories are groups, whereas interval and ratio are what type of variables? Quantitative variables. The responses have real numerical value. The responses are all going to be numbers. So if all variables can be classified as either nominal or ordinal, which are qualitative or categorical variables, or they could be interval and ratio, which are quantitative variables, well, statement number 1 is then true. What about statement number 2? Categorical variables can be continuous variables. Well, what do I mean by categorical variables? What types of level of measurement are these? Well, categorical variables, categories, groups. So if our responses are going to be categories, those types of variables are going to be nominal or ordinal. So let's think about this. First part of the statement is talking about nominal and ordinal variables. So can these types of variables be continuous variables? Well, what do we mean by continuous? Well, when we mean continuous, we mean that whatever our responses are, those responses can be broken down further. And those responses can be broken down further. So the units can be broken down into smaller pieces. Well, can categories be broken down into smaller units? Can ethnicity be broken down? Or can favorite color? No. And what about ordinal variables? Strongly agree to strongly disagree, or pain level from 0 to 10, or 5 is moderate, 0 is no pain, 10 is extreme pain. Not really. So categorical variables can't be continuous variables because continuous variables means that our variables are quantitative. They have numerical value. And we know that numerical value variables are not categorical. So statement number 2 is false. All right, and statement number 3, quantitative variables can be discrete variables. Well, when we think about quantitative variables, what types of level of measurement are we talking about? Interval and ratio. So can interval and ratio variables be discrete? What do we mean by discrete variables? Well, this is the opposite of continuous variables, where continuous variables, the responses can be broken down into smaller units. Discrete variables cannot be broken down into smaller units. Essentially, your responses are whole numbers. Can you think of an example of a discrete variable? How about the number of times you went to the restroom? Number of times you went grocery shopping? What about continuous variables? How old are you? How much time did it take for you to get to school today? These responses can be broken down, but number of times you went to shopping, number of times you went to the restroom, those cannot be broken down. So quantitative variables can be discrete variables. This is true. Therefore, our final answer is E. Statements 1 and 3 are true. Question number 4, which is really on here is question number 5, so that's just a little typo. Okay, so proportions are expressed between what two numbers, while percentages are expressed between what two numbers? Well, let's start with the second half of this because this probably is going to be easier. Percentages, well, we know a percentage can be ranged from 0 to 100, so we can automatically get rid of responses B and response D. So we're second looking at A and C. So proportions are expressed between what two numbers? 0 and 1, or negative 1 and positive 1? Well, negative 1 to positive 1 is for Pearson's correlation coefficient, where negative 1 is going to be a perfect, strong, indirect relationship, and positive 1 is a perfect, very strong, direct relationship. Therefore, A is our answer. Proportions range from 0 to 1, so any decimal between 0 and 1 is considered a proportion. The percentages are expressed between 0 and 100. So then how do we convert a proportion to a percentage? Multiply by 100. Make sure you show that piece of work. All right, question number 6, true or false. We have 4 statements here, and we see we have 2 box and whisker plots at the bottom, one for Jacob's science scores and one for Shiny's math scores. So let's start with statement number 1. Jacob and Shiny have the same range of scores. Let's look at Jacob's range. Well, what does the range consist of? The range consists of max minus the min, where our max for Jacob's science scores is 85. His minimum score is 45, so he has a range of 40. And what about Shiny's range of math scores? Well, her highest is 100%, and her lowest is a 60, so her range is also 40. Therefore, Jacob and Shiny do have the same range of scores. Second statement, Jacob tends to do better in science than Shiny does in math. Well, What piece of information on the box and whisker plot did you look at in order for you to answer this statement? Well, we know we have a minimum, we have a Q1, we have a Q2, we have a Q3, and we have a maximum, we have a range, we have an interquartile range. So all of those information, all of those statistics, what would we need to know in order for us to answer this? Well, there's one key word, tens. What do we mean by tens? How often, right? And when we think about tens, and often in central tendency, typical, oh, central tendency. And what central tendency measure do we know from a box and whisker plot? We know we can get the mean and we can get the median. Is the mean provided here for you? No, it's not. Therefore, we're only stuck with the median. And what's Jacob's median science score? Looks to be about in 68 or so. And what about Shiny's median math score? A little bit better, about 83 or so. So does Jacob tend to do better in science than Shiny does in math? No. He actually does worse because his median score, which is this measure of central tendency, is about 68 compared to Shiny's median math score, which is 83. Third statement, Shiny's scores are more skewed than Jacob's. So how do we tell skewness? Well, we know skewness is all about how far off the midpoint is, or how far off we are from the midpoint. Well, we see that the median is off to just the right a little bit, which means that we probably have a little bit more scores to the left, but we really don't know too much, and we don't have a mean, so we can't say which side the mean is relative to the median. Let's look at the distances between all of our pieces of information in our box and whisker plot. The distance between the minimum and Q1, distance is about 10 for Jacob. What about Shiny? Distance of her minimum to her Q1, also about 10. Okay, well, that looks the same. And what about the distance between Q1 and Q2 for Jacob? That looks to be about 10, 55 to about, what did we say before, about 68. It's a distance of about 13 points. And what about Shiny's math scores from Q1 to Q2? 70 to about, what did we say earlier, about 83, so about 13 units as well, okay? So far they're the same. So let's look at Q2 to Q3 for both. It looks like they're pretty much the same distance as well. And Q3 to the maximum looks to be the same as well. So in this case, really, it looks like the distribution are all the same, even though the median is off slightly from the middle. So Shiny's scores are not more skewed than Jacob's because we see the box and whisker plot is nearly identical. And the last statement, the middle 50% of Jacob's scores equals the middle 50% of Shiny's scores. Well, what do we mean by the middle 50%? Do we mean the median? No, the median is the 50th percentile. It's the 50th position, the very middle position. But the middle 50% is really the interquartile range, which is the box. So let's look at the interquartile range for Jacob. Q3 minus Q1, 75 minus 55, about 20. And what about Shiny's interquartile range, her middle 50% of scores? Q3 minus Q1, 90 minus 70, about 20. So, yeah, this is true. They're both equal. They're both equal to 20. Question number 7. We have a descriptive statistics SPSS output here. And we see we have sample size, minimum, maximum, the mean, the standard deviation, skewness, and kurtosis. And how many variables do we have? We have 5 variables. We have age, BMI, 6-minute walk, pain level, and race ethnicity. So to answer this question, which answer best describes the distribution of pain levels among this sample? Well, let's look at pain levels. This is our fourth variable. So what would we need to know in order for us to answer this question? Well, we see our possible responses: skewed to the left and more peak, skewed to the left and flatter, skewed to the right and more peak, skewed to the right and flatter. So what would we need in order for us to answer this, given the responses we have? Do we need to look at the number of people, the minimum, the maximum? We need to look at skewness and kurtosis. So let's look at skewness first. What is our skewness statistic for pain levels? 0.443. So does this skewness statistic mean that it's skewed to the left or skewed to the right? Well, since it's positive, it's skewed to the right. What about our kurtosis statistic? Negative 0.993. So does this mean that our distribution is more peaked, or does it mean that it's flatter? Well, since our kurtosis statistic is negative, it means that it's flatter. Therefore, our answer is D, skewed to the right and flatter. All we're looking at when we're looking at and determining skewness and kurtosis is the sign. Is there a negative sign or not? If we don't have these statistics, we can also look at the mean relative to the median. But if you don't have the median, you can't figure that out. So know that we can always figure out skewness and kurtosis either by comparing the mean and the median to each other, or seeing what our actual skewness statistic and kurtosis statistics are. Question 8. Same descriptive statistics. Calculate the following. What is the range for age? So the formula for range is maximum minus the minimum. And what is the maximum minimum for age? Well, it's our first variable, and we see 51 is our minimum, 91 is our maximum, and we have 103 people. So we set this up, and we get our answer of 91 minus 51 equals 40 years. What about the coefficient of variation for BMI and 6-minute walk test? So what's the formula for coefficient of variation? Well, that's 100 times standard deviation divided by the mean. So we need to figure out the CV for both. So here's BMI, 22.05%. And here's 6-minute walk, 20.28%. So now that we have our CVs for both, we just need to compare them both and see which variable has more variation. Well, because BMI has a bigger number, it has more variation. Question number 9. Calculate Pearson's correlation coefficient between exercise and GPA. Well, what do we know Pearson's correlation coefficient to measure? What is it all about? Why do we even use it? It's when we want to investigate and learn about the relationship between two different variables. And we see our two different variables in case are exercise and GPA. So what's the first step? We need to get our labels. And once we have our labels, we go ahead and work through it. So here are our labels: x squared, exercise squared, y squared, GPA squared, and x times y, exercise times GPA, and we fill those out. And we need to make sure that we have our summation, and once we have that, we work down the columns to add everything up. Once we've worked through all these numbers, we just plug and chug into our formula. Make sure you memorize this formula. So now it's just making sure that you plug in the right numbers accordingly. So this is what you should have got. We have 5 cases, 5 individuals. And once you plug it in, and you do the math correctly, you should have gotten R is equal to negative 0.77. Given that this is our Pearson's correlation coefficient, what is the direction? Is it direct or indirect? Because it's negative, it's indirect. And what about the strength of the correlation? How strong is the relationship between exercise and GPA? We know that is if one goes up, the other one goes down. The more you exercise, the lower your GPA. Maybe the lower your GPA, the more you exercise. We really don't know which direction. But how strong is this relationship? It's actually a pretty strong relationship. Right, 0.77. We look at the absolute value of our Pearson's correlation coefficient. 0.77 ranges falls within 0.6 to 0.8, indicates a strong relationship. So the relationship between exercise and GPA is a strong indirect relationship. Question 10. Calculate the inter-rater reliability between Meg and Chris. Anybody know the reference here? Family Guy, maybe? Alright, so calculating the inter-rater reliability. Well, how do we set this up? This is the simplest formula and equation and calculation for reliability coefficients. It's simply the number of agreements divided by the number of possible agreements. So you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible agreements. And how many times do they agree? 1, 2, 3, 4, 5, 6, 7. 7 divided by 12 gives us a reliability coefficient for inter-rater 0.583. Last question. You see we have all sorts of data here. What is the internal consistency reliability coefficient for all items? As soon as you see internal consistency, you should automatically think about Cronbach's alpha. Looking to see how much do all of these items, or one of these items, measure the same dimension, or the same concept, the same domain. In this case, we want to look at physical ability impact, seeing whether all of these measure that domain. So the internal consistency reliability for all the items, well, how many items do we have? We have 12 items, and our Cronbach's alpha, 0.939. Would you want to delete any items to increase the reliability of this tool? Well, we need to look at our Cronbach's alpha, 0.939, and compare any of the items in our item total statistics table in the last column to see whether or not there are any Cronbach's alphas that would be higher than what we already have with all the items to increase the reliability. If we delete any of these items, the Cronbach's alpha will change to that respective coefficient. So if we look at the first one, taking care of one's personal needs. If we deleted that item, Cronbach's alpha would change to 0.938. Does that mean that our reliability from 0.939 to 0.938 got better or worse? It means it got worse. Because remember, we want our reliability coefficients to be positive and as close to +1 as possible. What about bathing yourself using tub or shower? If we deleted this item, our Cronbach's alpha would increase to 0.940. Huh, look at that. That's a good thing. So do we have any other items that if we deleted it, our Cronbach's alpha would increase? Nope. So in this case, the only item would be bathing yourself using a tub or a shower. Okay, make sure you review this study guide if you haven't already. If you have any questions, come see me in office hours. Otherwise, good luck on the midterm. You'll do great.